So here is the working, and as you can see, we have our enclosed region. I called it R, and then we have the partial derivatives of the F2, and also F2 with respect to x, and minus the partial derivative of F1 with respect to y dx dy. So you just come here and replace, you work out these partial derivatives. So you take the partial derivative of x with respect to of f2 with respect to x, and this is what you get. We all know how to work out that. And then the partial derivatives of f1, this one, with respect to y. And then once you have this, you said when you're calculating partial derivatives, maybe to just explain what is happening, you treat like for the first case with respect to y, any other, like for the first one, f2 with respect to x. So like you can see this one, you have gotten 2y plus 2. How do we get that? You deal with this when you have just the x value. For the other one that does not have the x value, you treat it as constant. The same applies to when you're doing the partial derivative of f1 with respect to y. So then you expand the brackets. So you have 2y plus 2 minus 2y minus 7. So 2y minus 2y, this is, they cancel out. Plus 2 minus 7, that is plus 2 plus 7, that will be 9. So it will be 9 dx dy. Remember, you have two integral signs and then dx dy. You can see from basic mathematics, the circular disk has an area of pi because it is circular in nature. So the value will be, instead of 9, you'll have 9 pi. So we have first we have solved this. Then the next step is to verify that this satisfies Green's theorem. So after that, uh, so we have found the 9 pi. So you come and show that the line integral in 1, that is the C, that is the circular circle, then we are going to orient it the anti-clockwise direction, just like we said in example 1. And uh, we know this the inequalities, because you can see here it is x squared plus y squared. So when you take an example and say RT is equals to cos t and then sin t, then when you integrate the same, when you integrate cos, you get negative sine. When you integrate sine, you get a positive cos. So replicating this example in what we have here, in what we have there, we will have f1 is equal to y squared minus 7y, and putting it in terms of sine and cos. So taking y to be our sine, so you'll have, because it is y squared, and we take y to be sine, you'll have sine squared t. And for negative 7y, you'll have negative 7 sine t. Then for the f2, f2 is 2xy plus 2x, which will be, we said y is sine, x is cos, so this will be 2 cos t sine t plus 2 cos t. Then we verify this using the Green's theorem, and this will be easy because now you take the curl integral, that is the integral of the closed section, that is the f1 x1 and plus f2 y prime dt. So, and we know what our limits. So with that in mind, we are just going to now to integrate the whole of this we are going to expand it and then integrate it with the respect to the limits that we have seen. That is from 0 to 2 pi. So here it is, the expansion of the same. So just come and put the sine squared t minus 7 sine t, which we saw it is from the f1, that is y squared minus 7y in terms of sine and cosine. So just come and put it here, sine squared t minus 7 sine t, and then the minus sine t, because it is f1 x1. So our f1 is sine squared t minus 7 sine t, and then x1 it is sine t, then plus, then the f2, our f2 is 2 cos t sine t plus 2 cos t. That is what we did there, and then you can factor out 2 because 2 is common in both cases, because we have 2 cos t sine t plus 2 cos t. So just factor out 2. When you factor out 2, you remain with 2 cos t sine t plus 2 cos t. So that is our f2. Remember, it is f2 and y prime. So our y prime from our equation here, we saw, we said our y prime to be cos t, because we integrated to sine t, then we integrate that, you get cos t. So it will be 2 into bracket cos t sine t plus cos t cos t, close that bracket, then the value for y prime, that is cos t dt. Then with that, you just integrate it the normal way and then put in your limits. And for you to get these values, you set your calculator in radian mode. Set your calculator in radian mode so that you're able to execute sine cubed t. Where do we get sine cubed? You just open up this bracket. You can see from here it is sine squared t and then times negative sine t. So this will be a negative sine cubed t. Higher. For the negative 7 sine t times this, you have negative 7 sine squared t. Then note the change of sign, because this is negative 7 and this is negative sine. So negative times negative, it is positive. Positive. That's why we have plus sine squared t. Then the last part is plus 2 cos squared t sine t. You just open up this, because it was 2 cos t, then times this. So 2 cos squared t sine t, because it is here. And then the last part, it will be 2 cos squared t dt. So once you have that, we put our limits. Our upper limit is 2 pi, our lower limit is 0. And this is what you get, 0 plus 7 pi minus 0 plus 2 pi. And then, so this is 0, 0 to cancel out. Then 7 pi plus 2 pi, you get 9 pi. So for you to say to be said that you are verified, you'll have 9 pi as our final answer here. Remember what we got when we integrated our initial equation here? We got 9 pi, remember here. So we have verified as per the instructions of the question. We have verified that F1, which is equals to this, and F2 is equals to this, and C, they satisfy the Green's theorem. So you can copy that in case of any question. Let me get to know. Any questions?
In German, you would say Vielen Dank.
So once you copy that, attempt this example. Attempt this example. That is question number 2. Just copy it, attempt it, then share with me via the email. So attempt example 2, and let me see your solution. The solution are there on the portal, but I would wish that you don't copy them. So they are there for reference, but I want you to attempt them. Do them using your own mind, and let me see the progress so far. Also, before the end or before 2 p.m., ensure that you log into the portal and mark yourself present on the registers there. Next class, we are going to deal with the Stokes theorem. If there is no question, that will be the end of our class. Unless there is somebody with a question. If there is nobody, that should be the end of our class. Remember to do that question and share with me before the end of the day. And any other question that you might have. Remember to, once we are done here, log into the portal and mark yourself present there. So have a good afternoon.